Hi, grade 11s. Today we'll be looking at the domain and the range of a hyperbolic function. Recall that the domain is about the x values and the range is about the y values of which a function can take. A hyperbolic function can be represented in this format in an equation where a, p, and q are constants, meaning numbers. Remember that q is about the graph going up or down, which therefore means p will be about the graph going left or right. So that would be for the vertical shift and that would be for horizontal shift. Now in grade 10, you learned that the graph of a hyperbola can have the dotted lines, these, which you call them asymptotes, and the arms will be like this. If the a value is a negative number, the arms will be here. So a is less than 0, can be a negative 5 or negative 3.5. If a was a positive number, a is greater than 0, could be positive 7 or 4,3. It means that the arms of that graph will be in the first quadrant and in the third quadrant. Let's check how some of the questions are asked. Let's say this one says, determine the range and the domain of this function here, y is equal to 8 over x plus 2 plus 1. Now, it means that the graph here has a horizontal shift. This graph of ours has moved. I'll solve here for x. I say x plus 2 equals 0, so x is minus 2. It means that the graph has shifted 2 units to the left. Now, this one here says plus 1. It means that the graph has moved up 1 unit because it's a plus 1. Now let's check. Remember that if a was positive, the graph will look like this. Now when you say the graph shifted 2 units to the left, it went to the left 2 units. Note that even the asymptotes are moving. And now going up 1, it's going up. The asymptote is also going 1 unit up, which therefore means my graph now has got a horizontal asymptote like that at 1 and a vertical asymptote like that. And since a is positive, my arms are there and there. So what is the domain? We say that this line here, dotted line here, is at minus 2. That dotted line there is 1. So the domain is about x values. So this graph can take all x values from negative infinite all the way, but except on the asymptote, because the graph won't cut the asymptote, and then it continues. Therefore, we say the domain is x is an element of real numbers, can take all real numbers, but it cannot, x is not equal to, it can't take x equals minus 2, minus 2. What about the range? The range we set are the y values. So the graph can take all the y values except when it hits the dotted lines, asymptote, at 1. And continues, etc. Therefore, the range is y is an element of real numbers, all numbers, but y cannot be equal to the numbers on 1 there, so it can't be 1. Let's look at another example. This one here. We say here we want to see it's shifted, right? So we solve for x. X minus 3 equals 0, so x equals 3. So which means that the graph shifted horizontally 3 units to the right. And then this one is a minus 2. So that means that this graph went down 2 units. It went down. Okay? Now, originally, because that is a minus 6 there, it means that the graph, the arms were there and there. Now we said it shifted 3 units to the right. So 1, 2, 3. So I've got the dotted lines there. And then 2 units down, just 1, 2 units down, which therefore means our graph now is there, the asymptotes are there, and the other one, 2 units down, there. And we said the arms are negative, so it means that the graph would be like that. Note that we're just making sketches here. We're not like so strict on this. So this number here is a 3, and that number there is minus 2. So the domain are the x values. The graph can go all the way to the right except when it hits 3. Graph can't cut there and then continues. So the domain, x element of real numbers, all numbers, but x cannot be equal to a 3. Similarly, the range, the y values, is y is an element of real numbers because can take all numbers except at minus 2. So except when y is equal to minus 2, so y cannot be equal to minus 2. Let's look at another example. Let's look at this one. This one here. Check here. So the graph didn't move, right? It didn't move. It stayed there, right? And then what else? This one says it's a plus 1.5. So the graph went up. How many units? How many units there? It's 1 unit up, 1.5 unit up. Okay? So this is a negative number, which means that the arms of the graph originally they were there, right? Now look at the graph here. Note that we said that there is asymptote here, right? Check there. It's on the y-axis, and the equation on the y-axis is x is equal to 0, because if the vertical line is here, it should be x equals to minus 1. If it's here, it will be x is minus 2. So here is minus 1. Here, x is equal to 0. So our domain here will say x is an element of all real numbers, but x cannot be 0 because it didn't move. So the asymptote is at x equals to 0, but it moved up 1.5 unit. It went up to there, so which means that it's there. So it means that if we were to draw this graph of ours like correctly, so we'll have the asymptote still there, and but we'll also have another one there which will be at 1.5. This one is at 1.5 there. So therefore the range would be y is an element of real numbers, but y cannot be equal to 1.5. Okay, now let's look at another one. Note that as we are sketching here, at the moment we are not looking at the x-intercept or the y-intercept, but at some stage you may be asked to draw the graph accurately, putting all the x-intercept and the y-intercept. Let's look at this interesting one. You can see that it is not like similar to all that we're doing. It is even the equation here is not in that format. But you can manipulate this and see what happens. Check, if I take a 2 to the other side, so I'll be left with y plus 1 multiplying a 4 minus x, which is equal to a negative 2. That looks nice now. No, let's look at this. You see here, this thing here is multiplying that. Let us get rid of this. How do I get rid of this? I divide both sides by this. So it means that divide this one by 4 minus x, divide this one by 4 minus x, which means that on this side I'll be left with y plus 1 equals, now I'll have a minus 2 over the 4 minus x. All right, but still I've got a problem here because I've got a plus 1. I must take 1 to the other side because you must always be left with a 1 y on the left hand side. So I take a 1 across, so I've got now y is equal to a minus 2 over a 4 minus x, then minus 1. Now there's a problem here, but notice if you look clearly here, this was x plus something, so we must start with an x here. If you look at this one here, this is 4 minus x, and you'll recall from grade 9 that if this is 4 minus x, I can swap those around and change the sign in front there or above there. Therefore, this is same as y is equals. Change the sign, now it becomes positive 2 over. Now, these have swapped now as x minus 4, but this is minus 1. Now, this looks familiar because it means that the graph of ours, that's a positive 2, which means that the arms were there and there, but then they shifted it 4 units to the right, 1, 2, 3, 4 units to the right, and then what happened next? Then they shifted the graph 1 unit down, then 1 unit down, which means that if I were to draw this graph of ours will be on the x, the vertical asymptote will be there, and the horizontal asymptote will be there, where the x value there is a 4, because we'll solve for x here. Remember, we say x minus 4 is equal to 0, so x is equal to 4. That's how I got that 4 over there. And then this one is going down 1 unit down. It went down by 1 unit, so we've got a minus 1 there. So which means that our arms now, because that's positive, the graph will be somewhere there and also somewhere there. And therefore, we can say that our graph has got the domain of all x values, because this graph here, although I did that, this thing says that all the way the graph is approaching that, right? It's also approaching, so it's all the way to the left. So it's x is an element of real numbers, but x cannot be equals because it goes all the way, but once I hit 4, I can't touch 4, so x can't be 4. Then the range will be y is an element of real numbers, but y cannot be equal to, this graph can go, can't reach minus a 1, so therefore x cannot be minus 1. We've answered all of these questions. All right, let's look at what you can do from your textbook, Siyavula textbook grade 11, chapter 5, 5.3. It says hyperbolic functions. Just do exercise 5.10. Although in the textbook they don't say sketch the graphs as I did, this makes things easier for you to see if the graph has been drawn for you. And then otherwise, if you don't draw them, we won't see where the asymptotes are, and then you may make mistakes. So draw the graphs so that you've got a sketch, and then you can answer the questions. Okay, good luck, ladies and gentlemen.